Okay, so looking at what you've got going here, you said you were having an issue um, finding the intersection where these two uh, lines intersect. So just remember, what is the whole point of what we've been doing up to this point in the class? What was the point of learning all the matrix stuff and reduced rational and form and all that? Well, it was so we don't have to revert to our old methods for finding intersections. We can just say, hey, I want to know where those two lines intersect. So I'm going to pop them in a matrix, 1, 2, 12, and then 2, 1, 12. And I'll let the calculator spit out a reduced row echelon form for me. And when you do that, you end up getting 4, 4. So what that says to me is we now know that the this point here, the intersection is 4, 4. But don't forget, we're looking at our entire shaded region. That point may or may not actually be in our shaded region. So when you do your graph, do your shading as well. So I assume this is A and this is B. You can see they're both less than. So when we do our test points, we can say 0, 0. 0 plus 0, 0 plus 0 is less than or equal to 12. That's true, so we're shading down. The other one, 0 plus 0 is less than or equal to 12. That's true, so we're shading down. And then we have the restriction that x and y both have to be greater than or equal to 0. So our shaded region is this area right in here. So we have to ask, where are all of our corner points if we were to kind of shade this in nice and solid? And you would see we've got one where you predicted run right there. We also have a corner point right there, and right there. Everywhere it turned directions. So now we have to say, well, maybe this is our corner point, maybe the 4, 4 is our corner point, but maybe one of the other ones is our corner point. So we need to find all of those, rephrase, they're all our corner points, but maybe it's our maximum. That's what we're looking for. So we're going to take our 4, 4, substitute it into here, and see, okay, so if I sub in, for 4, 4, I get, what does P equal? P would end up being 8. So is 8 really the maximum? If it is, we go ahead and put that in. And if it's not, we'll look at the other points. So now look at this one, for example, and find this value down here for B. Okay, and I just went and got my bearings. So that is our B equation. That's the x-intercept from the B. So that's this point right here is 6, 0. This point up here is the y-intercept of the A equation. So that's 0, 6. So the other 2 points we need to check, we've got, here I'll scoot them down below so it's a little easier to read. So for our corners, there we go. For our corners, we need to check literally all 3 corner points. We need to check the 4, 4 corner, the 6, 0 corner, the 0, 6 corner, and really truthfully there is a 4th corner, but it seems silly to even bother checking it because it's 0, 0, and we all know when we substitute that in that we're going to get 0. So that's not going to give us a max. If it was asking for a min, that would be it. So long story short, the equation we're trying to min to max though is just x plus y. So x plus y makes 8, x plus y makes 6, x plus y makes 6. So therefore, we're going to have a p equaling 8 at 4, 4. I hope that made sense.